This is problem number 2 for assessment number 7. In this problem it says find the limit as h approaches 0 of this expression right here. So what we want to do is we want to, first of all, we want to try and plug in 0 to see if it's defined at 0, because if it's defined at 0, we'll know our limit basically. So we'll plug in 0. We get on top, we get 15 times 0 plus 1. So we'll end up with root 1 minus 1, which is 0. But on the bottom, we get a division of 0, which is the issue. We can't divide by 0. So this is like an indeterminate form. What we want to do is we want to multiply. Whenever I see a radical with another term being added or subtracted, I think, why don't we use the conjugate? So let's multiply by the conjugate. Root 15h plus 1 over root 15h plus 1 out here. When I multiply, I end up with the limit as h approaches 0 of this multiplied times this will give you just 15h plus 1. So when you take the radicals and multiply them, the radicals cancel. I take this radical times the 1, and I get plus radical 15h plus 1. Now I take the negative 1, I multiply it times this radical, and that'll be minus radical 15h plus 1. Negative 1 times 1, it's going to be minus 1. All over. On the bottom, I'm trying to cancel the h out. That was our problem to begin with, so when we plug in the 0, we can't divide by 0, so I'm going to just leave this as a multiplication and not do any distributing. That equals limit as h approaches 0. This will cancel with this. 1 and negative 1 cancel. And I end up with 15h over h root 15h plus 1 plus 1. The h's cancel, and I'm left with limit as h approaches 0, 15 over radical 15h plus 1 plus 1. Now I can see if let's just check to see when I plug 0 in if this works out. So I get 15 over, I'll end up with root 15 times 0 plus 1 inside the radical plus 1 out here. So I get 15 over, this will just be root 1 because this cancels. So I get root 1, which is 1 plus 1 because of this plus 1 equals 15 over 2. So the limit as h approaches 0 of the original function is 15 over 2.